Good morning, viewers. Today in Applied Physics, we shall be learning about heating effects of current, electric power and their applications. You have studied about electricity right from your junior classes. You know it is the most widely used form of energy. You cannot see electricity, but you can very well see the effects of electricity. Electricity can produce different types of effects. Basically, the effect of electricity is to convert electrical energy into other forms of energy, like you see light that you see in electric bulbs and electric tubes, heat that you are able to feel with the electric heater, then electric iron, electric toaster, electric ovens and so on. Now, when electric current flows in a circuit, it produces a number of effects. These are heating effect, luminous effect, light effect or photoelectric effect, then chemical effect and magnetic effect. Have you ever checked the body of electric motor or the body of fan or bulb after they have been running for a long time? तो बॉडी ਨੂੰ ਟੱਚ ਕਰਕੇ ਦੇਖਿਆ ਹੋਵੇਗਾ, ਜਾਂ ਫੈਨ ਦੀ ਮੋਟਰ ਨੂੰ ਟੱਚ ਕਰੋ ਜਾਂ ਬਲਬ ਨੂੰ ਟੱਚ ਕੀਤਾ ਹੋਵੇ। ਕਦੇ ਅਗਰ ਚੱਲਦਾ ਬਲਬ ਫਿਊਜ਼ ਹੋ ਜੇ ਜਲਦੀ ਜਲਦੀ ਤੁਸੀਂ ਹੱਥ ਨਹੀਂ ਲਾਉਂਦੇ, ਕਿਉਂ? Have you noticed the temperature of any electrical device before and after long run, or it has been glowing for a long time? Do you find that electrical devices become warm after a long run? If your answer for these is yes, then do you know why electrical devices become warm after long run? So, to give the answers of all these, today we shall be learning about the heating effect of current. In this unit, I will first tell you about the basics which you might have already learned, that is electric current, resistance, Ohm's law, then heating effect of current, concept of electric power, concept of energy, that is electrical energy, units of electric power and electric energy, and finally we will learn about the applications of heating effect of current. What is electric current then? All the applications of electricity are dealt with electric current. Basically, it is the electric charges which move through some region of space. You can transfer energy to a device in an electric circuit, and this mechanism of transferring electrical energy is called electrical transmission. Then what is electric current? The rate of flow of charge through some region of space is what is called electric current. ਜਦੋਂ ਕਿਸੇ ਸਪੇਸ ਦੇ ਵਿੱਚ ਰੀਜਨ ਦੇ ਵਿੱਚ ਚਾਰजेस ਫਲੋ ਕਰਦੇ ਨੇ ਤਾਂ this flow of charge per unit time is what is called electric current. Charge flowing per unit time. The SI unit of current is ampere. 1 ampere is the current which, when 1 coulomb of charge flows through a wire for 1 second, and for current the symbol is I. Now, if you see in this diagram, there is an area, surface area, you see. The charges are flowing. These charges are assumed to be moving perpendicular to the surface area. Now, if in time delta t, delta q amount of charge passes through this area, then we define average current as delta q upon delta t. The direction is conventional direction of current, positive to negative. Electronic direction is from negative to positive. Now, you apply a potential difference across the conductor. What happens is electric field is set up in the conductor. This electric field exerts an electric force on the electron. What is electric field? Force per unit charge. So, when electric field is set up, the electrons, they experience electric force. Initially, the electrons were moving randomly, but on the application of potential difference, the motion of electrons is no longer random. If you see here in the diagram, this zigzag black lines that you see, they represent the motion of a charge carrier in a conductor when electric field is applied. Now, the net drift speed is small. If you see here, there are sharp changes in the direction. This is because there have been collisions at these points. So, the sharp changes, you see the charge was moving this way, it immediately moves this way. This change in direction is because of the collision with the ions or atoms or with other electrons. Net motion of electrons is opposite to the direction of the electric field. In the presence of an electric field, in spite of all the collisions, the charge carriers slowly move along the conductor. This speed, this average speed with which the charge carriers move is what is called drift velocity. Means the electrons drift through the conductor. The electric field exerts forces on the conduction electrons in the wire, and these forces cause the electrons to move in the wire and create a current. The electrons are not coming from anywhere else, they are already inside the wire. The only thing that happens is that when you apply the battery sets up the electric field, and these electrons, they respond to the electric field. Basically, battery is not supplying the electrons are inside the wire. Battery just establishes the electric field. Ohm's law, it states that for many materials, the ratio of current density to the electric field is a constant that is independent of the electric field producing the current. Most metals obey this law. So, sigma is J upon E, J is current density, E is electric field, or J is equal to sigma into E. Those materials which obey Ohm's law are called ohmic materials, but all the materials do not obey this law, and the materials which do not obey this law, they are called non-ohmic. Basically, this law is not a fundamental law of nature. It is an empirical relationship which is valid only for certain metals. This is a photograph of George Simon Ohm, who lived from 1789 to 1854. He was a German physicist, and he has given us the idea of resistance In the case of heating effect of current also, we have to deal with resistance. And he discovered these proportionalities, that J is proportional to E, and you have been saying I is proportional to E, that the current flowing through a wire or a conductor is directly proportional to the potential difference applied across it, provided the physical conditions remain constant. Physical conditions केड़ी हैं? Temperature, pressure, environment. I is proportional to V, or V is proportional to I, or V is equal to IR. So, in a conductor, the voltage that is applied across the ends of the conductor is proportional to the current flowing through the conductor, provided physical conditions remain constant. This constant of proportionality is called resistance of the conductor. So, resistance is V upon I. SI unit of resistance is ohm. If a potential difference of 1 volt is applied across a conductor and a current of 1 ampere flows through it, then the resistance of the conductor is said to be 1 ohm. ਜੇ 1 ਵੋਲਟ ਦਾ ਪੋਟੈਂਸ਼ੀਅਲ ਡਿਫਰੈਂਸ ਲਗਾਉਣ ਤੇ 1 ਐਂਪੀਅਰ ਦਾ ਕਰੰਟ ਫਲੋ ਕਰੇ ਤਾਂ ਅਸੀਂ ਕਹਿੰਦੇ ਹਾਂ ਕਿ ਉਸ ਕੰਡਕਟਰ ਦੀ ਰੈਜ਼ਿਸਟੈਂਸ 1 ਓਮ ਹੈ. Why does this resistance arise in a circuit? Because of the collisions between the electrons which are carrying the current. These electrons, they collide with the fixed atoms inside the conductor. So, this opposition that is offered to the flow of charge by the atoms or ions of the conductor is what is called resistance. Now, you apply a battery to a circuit. There is a chemical inside the battery. The chemical energy of the battery is converted to electrical potential energy. Chemical energy gets converted to potential energy. Because the electric field is set up by the potential difference of the battery, this causes the electrons to accelerate. Now, if the electrons are accelerating, this electrical potential energy is getting converted into kinetic energy. These electrons, they collide, and the collisions in the lattice structure transfers the kinetic energy to the lattice as thermal energy. So, chemical energy gets converted into electrical potential energy. Electrical potential energy gets converted into kinetic energy of the electrons, and kinetic energy finally gets converted into thermal energy. Thermal energy is a dissipative energy. So, it gets dissipated. Now, this is an ideal EMF source. One terminal is at higher potential, the other terminal is at lower potential. When you apply the battery, electric field has been set up. So, if this is a positive charge, it will experience a force Q into E, because electric field is force per unit charge. So, force is charge into electric field. So, when electric charge Q is moved by a non-electrostatic forces in a battery with the potential difference V, these forces do work. The potential energy of this charge is increased by the same amount. The work done gets converted into potential energy. So, the rate of delivering electric energy to the circuit is what is called averaged electric power. As these free electrons, they drift through the conductor, they constantly collide with the lattice ions. We have studied in the last slide that much of the energy they gain from the electric field is dissipated as thermal energy. The conductor gets heated up because thermal energy has been dissipated. बाहर निकल गई. The heating effect of a conductor in this way is what is called Joule heating. If you consider a positive charge, let us see what will be the change in potential energy. Potential energy will be equal to charge into potential difference. The battery applied across the resistor are, there are two ends A and B. If potential at B is VB, potential at A is VA, potential difference is VV minus VA multiplied by the charge. And if the charge tends to 0, the rate loss of potential energy is given by the rate at which the system loses electrical potential energy as charge Q passes through the resistor. You can find out the change by differentiating on both sides. You get I into delta V. So, this change in electrical potential energy per unit time is what is called electric power. So, power is equal to current into potential difference. This holds true for all the devices. Now, in a resistor, from Ohm's law, you know that V is equal to IR. So, P is equal to I into V, you put the value of V here, I into IR gives you I square R. If you put the value of I equal to V upon R, then V upon R into V gives you V square upon R. The system regains this potential energy when the charge passes through the battery. As the resistor obeys Ohm's law, so both these laws have been written again here. This means electrical energy is equal to what? Voltage multiplied by electric current multiplied by time interval. E is equal to V into I into T. How do you calculate electrical power? Electrical power is current into voltage, means it is the product of current and voltage. SI unit of electrical power is watt. Now, if you are given that in a circuit a potential difference of 110 volts has been applied, and if a current of 2.5 amperes is flowing through it, and you have to calculate the power of the circuit. So, P is equal to I into V, I is 2.5, simply multiply current with potential difference, this will give you the power of the circuit. So, what is electrical energy then? Electrical energy is a measure of the amount of power used and the time of use. कितनी power use ਕੀਤੀ, कितने time ਲਈ use ਕੀਤੀ, ਦੋਨਾਂ ਨੂੰ multiply ਕਰ ਦਿਓ, this gives you electrical energy. It is the product of power and time. If you calculate power in kilowatt, time in hours, you get energy as kilowatt hour. Normally, what the students see is kilowatt, they do not see hour written along with it, and they write this unit as the unit of power. Basically, remember, kilowatt hour is not the unit of electrical power, it is the unit of electrical energy. So, electrical energy is voltage into current into time interval, E equal to V into I into T. Then how does this energy get dissipated? You see, when the current is passed through a wire, you have found in many of the electrical appliances that they get heated up, because electrical energy gets converted into heat energy. Because when potential difference is applied across the two ends of a conductor, we have seen in the previous slides that electric field is set up. This electric field accelerates the electrons, these electrons, they are accelerated in a direction which is opposite to the direction of the electric field, and during their motion these electrons, they collide with the atoms of the conductor. So, we had seen that electrical chemical energy got converted into electrical potential energy, which got converted into kinetic energy. So, this kinetic energy of the electrons on collision with the fixed atoms appears as the heat energy. Now, let us discuss Joule's law of heating effect of current. We have seen that when a connector is connected across a source of EMF, means किसी बैटरी ਨਾਲ ਅਸੀਂ ਕਨੈਕਟ ਕਰਤਾ ਕਿਸੇ ਕਨੈਕਟਰ ਨੂੰ, ਤਾਂ ਕਰੰਟ ਉਹਦੇ ਵਿੱਚੋਂ ਦੀ ਫਲੋ ਕਰੇਗਾ। ਫਲੋ ਆਫ ਕਰੰਟ ਦਾ ਮਤਲਬ ਕੀ ਹੈ ਕਿ ਜੋ ਉਸ ਕਨੈਕਟਰ ਦੇ ਵਿੱਚ ਫ੍ਰੀ ਇਲੈਕਟ੍ਰੋਨ ਹਨ ਉਹ ਲੋਅਰ ਪੋਟੈਂਸ਼ੀਅਲ ਤੋਂ ਹਾਇਰ ਪੋਟੈਂਸ਼ੀਅਲ ਵੱਲ ਨੂੰ ਜਾਣਾ ਸ਼ੁਰੂ ਕਰ ਦੇਣਗੇ। ਜਦੋਂ ਇਹ ਇਲੈਕਟ੍ਰੋਨ ਕਲਾਈਡ ਕਰਦੇ ਹਨ, ਆਪਸ ਵਿੱਚ ਵੀ ਕਲਾਈਡ ਕਰ ਸਕਦੇ ਹਨ ਜਾਂ ਜਿਹੜੇ ਕਨੈਕਟਰ ਦੇ ਐਟਮਸ ਨੇ ਉਹਨਾਂ ਨਾਲ ਕਲਾਈਡ ਕਰ ਸਕਦੇ ਹਨ, ਤਾਂ ਇਹ ਆਪਣੀ ਕਿਨੈਟਿਕ ਐਨਰਜੀ ਨੂੰ ਹੀਟ ਦੇ ਵਿੱਚ ਬਦਲ ਦਿੰਦੇ ਹਨ। ਥਰਮਲ ਐਨਰਜੀ ਦੇ ਵਿੱਚ ਚੇਂਜ ਕਰ ਜਾਂਦੀ ਹੈ ਕਿਨੈਟਿਕ ਐਨਰਜੀ, ਅਤੇ ਕੰਡਕਟਰ ਦਾ ਟੈਂਪਰੇਚਰ ਵੱਧ ਜਾਂਦਾ ਹੈ। So, at each collision some part of the kinetic energy of the electron gets converted into heat, which increases the temperature of the conductor, and this is known as heating effect of current. Finding of Joule was that when current flows through a conductor, the heat that is produced in the conductor is directly proportional to the square of the current. Means जितना ज़्यादा करंट फ्लो करेगा उतनी ज़्यादा हीट प्रोड्यूस होएगी। डायरेक्टली प्रोपोर्शनल टू द रेजिस्टेंस ऑफ द कंडक्टर, जो कंडक्टर है उसकी जिन्नी ज़्यादा रेजिस्टेंस हो उतना ही ज़्यादा हीट प्रोड्यूस होएगी, उन्नी ज़्यादा हीट प्रोड्यूस करेगा वो कंडक्टर। और टाइम तो है ही, जिन्ने ज़्यादा टाइम ਲਈ ਤੁਸੀਂ ਕਰੰਟ ਪਾਸ ਕਰੋਗੇ ਉਨੀ ਜ਼ਿਆਦਾ ਹੀਟ ਪ੍ਰੋਡਿਊਸ ਹੋਊਗੀ। ਇਸ ਇਕੁਏਸ਼ਨ ਦੇ ਵਿੱਚ ਤਿੰਨਾਂ ਨੂੰ ਕੰਬਾਈਨ ਕਰ ਦਿੱਤਾ, Q is proportional to I square RT or is equal to I square RT divided by J। J ਕੀ ਹੈ? ਜੂਲਸ ਕੌਂਸਟੈਂਟ ਕਿਹਾ ਜਾਂਦਾ ਹੈ। What is J? 4.18 ਜੂਲ ਪਰ ਕੈਲਰੀ। तो ये ਜਿਹੜਾ है I square RT upon J, this is giving you heat in terms of calories। ਤੇ ਜੇ ਜੂਲ ਦੇ ਵਿੱਚ ਹੀ ਕਰਨੀ ਹੋਵੇ ਤਾਂ ਤੁਸੀਂ ਸਿਰਫ I square RT ਤੱਕ ਲਿਮਿਟ ਰੱਖਣਾ ਹੈ ਆਪਣੇ ਆਪ ਨੂੰ। You don't have to divide it by this constant J. This is only to convert into calories. What are the units of electrical energy? Work, energy, ਇਹਨਾਂ ਸਭ ਦਾ ਯੂਨਿਟ ਸੇਮ ਹੀ ਹੋਇਆ ਕਰਦਾ ਹੈ। It is joule। SI ਸਿਸਟਮ ਦੇ ਵਿੱਚ ਜੂਲ ਹੀ ਹੈ ਇਲੈਕਟ੍ਰੀਕਲ ਐਨਰਜੀ ਦਾ ਯੂਨਿਟ। ਬਟ ਕਮਰਸ਼ੀਅਲ ਯੂਨਿਟ ਆਫ ਇਲੈਕਟ੍ਰੀਸਿਟੀ ਵਿਚ ਯੂ ਕਾਲ ਐਜ਼ ਬੋਰਡ ਆਫ ਟ੍ਰੇਡ ਯੂਨਿਟ, ਜਾਂ ਜੋ ਅਸੀਂ ਘਰਾਂ ਦੇ ਵਿੱਚ ਕਹਿੰਦੇ ਹਾਂ ਕਿ 1 ਯੂਨਿਟ ਫੁੱਕ ਗਏ, 2 ਯੂਨਿਟ ਫੁੱਕ ਗਏ, that is called BOT, Board of Trade Unit, and one Board of Trade Unit is equal to 1 kilowatt hour. Then what is 1 kilowatt hour? 1 kW means kilowatt, H means R, means ਅਗਰ ਤੁਸੀਂ 1000 ਵਾਟ 1 ਘੰਟੇ ਲਈ ਯੂਜ਼ ਕਰਦੇ ਹੋ ਤਾਂ 1 ਯੂਨਿਟ ਫੁੱਕਦਾ ਹੈ, 1 ਯੂਨਿਟ ਐਨਰਜੀ ਯੂਜ਼ ਕੀਤੀ ਗਈ। 1 kilowatt means 1000 watt into 1 hour. 1 hour has 60 minutes. 1 minute has 60 seconds. 60 into 60 gives you 3600. 3600 into 1000, 36 lakh. Or you write it as 3.6 into 10 to the power 6. Watt into second is joule. So 1 kilowatt hour means you are using how many joules of energy? 3.6 into 10 to the power 6 joule of energy. You can verify Joule's law. This experiment is not in your course, but this is the apparatus that you can use for verifying Joule's law. You have to take a calorimeter with a lid on it, a heating coil, power supply, a rheostat, and a meter to note down the current, a thermometer to note down the temperature, a stopwatch, and add water to this. There is a lagging in the calorimeter, so that heat does not get dissipated to the surroundings. How do you proceed? You note the initial temperature, switch on the power supply and start the stopwatch. Adjust this rheostat if required, so that the current does not change, it remains constant throughout. Note the current using the meter and note the time for which the current is flowing using the stopwatch. Keep on stirring this water. Note the highest temperature. Find the change in temperature. This is one reading. Then you increase the current. Again take the second reading. ਜਦੋਂ ਇੱਕ ਰੀਡਿੰਗ ਲੈਣੀ ਹੈ ਉਸ ਵੇਲੇ ਕਰੰਟ ਕਾਂਸਟੈਂਟ ਰਹਿਣਾ ਚਾਹੀਦਾ ਹੈ, ਕਰੰਟ ਨਹੀਂ ਚੇਂਜ ਹੋਣਾ ਚਾਹੀਦਾ. Take at least 6 or 7 readings. This is a table that you can use. Plot a graph of I square against delta theta, means change in temperature. Now, if you plot this graph, you will find that change in temperature is directly proportional to the square of current. This is what we had said, that electrical heat energy is proportional to I square. Why then? Because heat produced is directly proportional to change in temperature, and change in temperature is directly proportional to square of the current. This means heat produced must be proportional to the square of the current. Power, you have been studying about this. It is the rate of doing work. Electrical power is generally expressed in watt or kilowatt. In DC and AC circuits with resistance loads, you can find out power. We have already studied that power is equal to current into voltage. If current is taken in amperes, potential difference in volts, then electrical power is in watt. This is the equation, P equal to V into I, and you know from Ohm's law that V is equal to IR. If you substitute V equal to IR, then I into R into I gives you I square R. If you substitute I, then I is equal to V upon R, you get P equal to V square upon R. So, you have got 3 formulae to calculate electrical power: V into I square R, and V square upon R. This is a diagram that you can examine. P here is taken in watt, I in ampere, R in ohm, V in volt. These are for power: V into I, V square upon R, I square R. If you want to find out current, V upon R, from this formula you get P upon V, and from this formula it is under root of P upon R. If you want to find out resistance, it is P upon I square, V upon I, V square upon P. If you want to find out voltage, that is potential difference, now P is equal to V square upon R, V is equal to under root of P into R. V into I is P, so V is equal to P upon I. P is equal to I square into R, so R is equal to P upon I square. So, you can calculate and use this diagram. How can you calculate electricity bills? Let us take an example. If you have an electrical refrigerator which is rated 400 watt and operates 8 hours daily, what is the cost of the energy to operate it for 30 days? How much bill will you get if the rate is 3 rupees per kilowatt hour, means one board of trade unit, electrical unit costs 3 rupees. You have to calculate the electrical